So welcome again to another part of telecommunication. This one is telecommunication part 3, and today we are going to continue to the part of power in AM wave. As we said before, in AM wave we have 3 amplitudes. We have the amplitude of the carrier wave, which is EC, but also we have the amplitude of the upper sideband frequency, which is MAEC over 2. This one is the amplitude of the upper sideband. But also we have the amplitude of the lower sideband, which is the same. It is MAEC over 2. So the amplitude of the upper sideband and the amplitude of the lower sideband, they are the same. So making a total of 3 amplitude. But there is a formula in current electricity saying power dissipated equals to current times the potential difference. I for current and V for potential difference. But in our case here, the potential difference we have is the amplitude. So the amplitude will stand as the potential difference. So we can say IV, or we can say V squared over R. So V stands for amplitude. So we have 2 formulas. Either you can say I times V, or you can say V squared over R. So root mean squared value of alternating EM wave. This is another formula found in alternating current. There is a subtopic called alternating current. So we say root mean squared value of alternating EM wave equals to, it will be V over square root of 2. So V is a peak value, So here we're going to use the amplitude. Amplitudes are going to stand as a potential difference, but this amplitude, they can't stand on their own. We are going to divide to the square root of 2. So this is a formula. It has some derivations. And coming back to carrier power, or PC, will be equals to, now because the amplitude of the carrier wave is EC, we're going to use this EC instead of V. But this EC won't stand on its own. It will be EC divided by square root of 2, then we square. So instead of putting V, we put EC over square root of 2, then we put it square. This stands for V squared. So V has been substituted by EC, amplitude, substituting the potential difference, and we put a square. Then we divide by R. So we divide here by R. So this one is a power in carrier wave. So simplifying, we are going to get, if we simplify, it will be EC squared over 2R. And this one is a formula of the power in carrier wave. So let us see the power in sidebands. Remember, we have 2 sidebands. We have the upper sideband and we have the lower sideband. And here we are going to use the amplitude of the sideband, either of the 2. We're going to use MAEC over 2. This one is going to stand as V. But this one also should be divided by the square root of 2, because we said the root mean squared of alternating EM wave is equal to peak value. You divide by the square root of 2. So here the formula will be MAEC over 2. This value is then divided by the square root of 2. Then we put a square, because the formula says the V squared. So we put a square. Then we divide by R. But remember, I told you we have 2 sidebands. We have the upper sideband and we have the lower sideband. So this power will be multiplied by 2, simply because we have 2 sidebands. So we multiply this whole value times 2, which will be equals to, MA squared, EC squared, you divide by 4R. So this one is a formula for power in sidebands. So here we have derived two formulas, power in carrier wave and power in sidebands. So here power in carrier wave is EC squared over 2R, and power in sidebands is MA squared EC squared over 4R. So let us now find the total power in AM wave. And in finding the total power in AM wave, we take the power in carrier wave, then we add the power in sidebands. So total power equals to power in carrier wave, then plus power in sidebands. We add the two powers together. So total power PT will be equals to EC squared over 2R plus MA squared EC squared over 4R. Okay, this one is a total power EC squared over 2R plus MA squared EC squared divided by 4R. Now, because EC squared over 2R is common in this place and here, so we're going to substitute. We're going to factor out EC squared over 2R. So we factor out EC squared over 2R. Then it will be bracket 1 plus. It will be MA squared divided by 2 bracket. So when we reach here, remember EC squared over 2R is equal to power in carrier wave. Power in carrier wave. So instead here of putting EC squared over 2R, we put power in carrier wave. So EC squared over 2R is equal to PC, or power in carrier wave. So power total will be equals to power in carrier wave bracket 1 plus MA squared over 2. So before continuing, I would like to recommend you subscribe to our channel. These classes are coming out for free. Hivi vipindi tunafanya bure. Tutatumia bando nyingi, tutatumia muda mwingi, lakini tutavitoa bure. Kwa hiyo support kubwa ambayo unaweza kaitoa wewe ni kusubscribe, ni kutoa like na kucomment. Usisahau kusubscribe. Let us now see the limitation of AM wave, and these ones as a disadvantage of AM wave. And maswali ambayo ni very common. You will be asked these questions in your exams. Very simple questions, very common questions. It's just you to give it your attention and time. So coming to the first limitation, we say that AM wave, it has noise reception. So AM wave can be interfered by noise. We said noise is unwanted information during signal transmission. So AM wave can be easily interfered by noise. Hii ni disadvantage ya kwanza. It is a first disadvantage. And the second disadvantage or limitation of AM wave, it has low efficiency. Uwezo wake wa kusafiri, uwezo wake wa kutunza information nakuwa ni kidogo. So it has a low efficiency. And the next limitation or disadvantage of AM wave, it has small operating range. The distance of transmission from the transmitter to the receiver is very limited. It has a small operating range. But another disadvantage of AM wave, we say it lacks audio quality. Ile sauti, audio quality is very low. But the another limitation of AM wave or disadvantage, it requires large bandwidths. Let us now jump to the frequency modulation or FM. So frequency modulation simply is a process of changing the characteristic of a carrier wave depending on the intensity of signal wave. Unachokibadilisha ni ile frequency, changing the frequency of carrier wave. Kwenye amplitude modulation tulisema tunabadilisha amplitude, but in frequency modulation what we are changing here is not amplitude, is not a phase. We are changing the frequency of a carrier wave depending on the intensity of signal wave. This one is frequency modulation. So let us see the advantage of FM. Ni faida gani zipo kwa kutumia FM? Ndio maana most ya watu wanapenda kutumia frequency modulation kuliko amplitude modulation. Kwa nini? There are advantage of using FM. Ya kwanza kabisa, it gives noiseless reception. Hii hapa frequency modulation cannot be interfered by noise. So FM haingiliwi na kelele. And the second advantage, we say that the operating range is very large. Inaweza ikasafiri umbali mrefu. And another advantage of using frequency modulation, it gives high fidelity reception. Ni kwamba inaweza ikasafiri umbali mrefu bila lose information. Zile taarifa hazipotei kwa urahisi. This one is also an advantage of using frequency modulation. So the last advantage of using FM, tunasema the efficiency of transmission is very high. Inafanya high efficiency of transmission. So the additional advantage of FM says that it has large number of sidebands. So it can be used for stereo transmission. Let us now see the disadvantage of using frequency modulation. Japokuwa frequency modulation au FM ina faida nyingi, lakini pia kuna hasara za kutumia frequency modulation. Ya kwanza tunasema a large wider bandwidth is required. Inahitaji bandwidth kubwa. So ile range of frequency of operation inakuwa kubwa. So to achieve it is very difficult. And another disadvantage au limitation ya frequency modulation, so the reception is limited to the line of sight. Kwa nasema line of sight ni ile clear pass. Ni clear pass between the transmitter and the receiver. Kwa tunasema ili kuwepo na efficient communication lazima kuwe na clear line of sight, lakini hii hapa frequency modulation imekosa hiyo clear line of sight. And another disadvantage of frequency modulation, tunasema FM transmission and receiving components are very complex. Vifaa ambavyo vinahusika kupokea na kusafirisha information kwenye frequency modulation, tunasema they are very complex. Kwa hiyo setting the equipment, sometimes buying the equipment inaweza ipo very expensive. Kwa hiyo hapa ni disadvantage ya kutumia frequency modulation. Na this one is the end of telecommunication part 3. Nipende kukaribisha katika mwendelezo telecommunication part 4 ambayo itaanza kuongelea space communication.